Alrighty, today on the Woken Way, 11.4, Intro to Derivatives. Woohoo! So this is calculus stuff, but we are practicing a skill that will then be applied in calculus, hence the name of our class, Pre-Calculus. So today we're doing the slope of the tangent line and the derivative, which are very similar. First of all, you should know that this right here you're going to memorize, and this is at a specific point. You don't even know what we're doing, you just know it's at a specific point. And this one you're going to memorize as well, and this actually gives an equation for the slope at any point. A very, very useful equation. Okay? So those are the two. You need to memorize this. This is the slope of the tangent line. Notice the definition says m, like slope y equals mx plus b, tangent line. And this over here is the derivative, f prime of x. They're used for very similar reasons. But this one actually gives you an equation or a formula to help you find the slope at any point, versus this is very specific to the point that they give you. So this is also the instantaneous rate of change of f with respect to x at a, and so this one says f of a plus h. The a is going to be the x coordinate of your point, and the f of a is going to be the y coordinate, so you can just know that that right there is your y coordinate of your point. So let's go ahead and get started. So this says use your graphing calculator to graph f of x equals x squared minus x. Well, I don't have my graphing calculator, so instead I'm going to factor it and graph it using intercepts. So I know there's one there, and then there's one at 1. And so I also know that this is a parabola, so it probably is going to look something kind of like this. Make myself a little note that this is not to scale, like it's not the most perfect parabola graph I've ever drawn, but it'll do the purpose of what we need. And then this says, then draw a tangent line to the graph of f at 4. Well, tangent lines are lines that only intersect the graph in one point. So let's hypothetically, maybe I'll make this point right here 4. So this graph is going to keep going. And so the tangent line is going to kind of come down like that, and it's going to touch right there. Really hard for me. I'm doing a really bad job because I don't have a ruler, but that's okay. I'm being flexible. Okay, so there's our tangent point. What this slope of the tangent line limit definition is going to allow us to do is find the slope of that line. So right now we know that this is the point 412 because it tells us it's at the point 412. And to write the equation of a line, you either need 2 points or the point and a slope, and we only have 1 point, and we don't have the slope, and we don't have another point. So what we're going to use is the slope of the tangent line. So you're just going to take that definition of the slope of the tangent line equals the limit. So this is a limit problem. So we need to make sure that we have that on every step until we evaluate. As h approaches 0 of f of 4 plus h, so you see what I've done is I've taken the a in the equation and replaced it with 4, because a is my x coordinate in this specific problem, minus f of 4, which by the way is going to be 12, all over h. Now what I need to do is plug in the f of 4 plus h into my function. So here's f of x equals x squared, and I'm going to be plugging in 4 plus h to that. So it looks like this, 4 plus h squared minus 4 plus h. And again, that's because there's two x's, and function notation says that you replace each x with whatever is in the parentheses. Minus f of 4. So you could actually plug in 4 here to figure out what f of 4 is, but I know it's 12 because this is a and f of a is 12. And that's coming from our definition up here. I'm just using that. We already wrote x and y. Okay, so then we just need to keep going here. So we go, which equals the limit as h approaches 0 of 16 plus 8h plus h squared. So I'm foiling. Oh my goodness, did you guys see I forgot that division by h? Tisk tisk. It's okay, mistakes are what help us learn, but we do need to correct them in order for that learning to occur. So we get there. Then I get the limit as h approaches 0, combine like terms. 16, -4, and -12 make 0. 8h and -h, so I get h squared plus 7h divided by h. And then I am going to factor out the h from the numerator. And then what's going to happen is that's going to cancel. So then I get the limit as h approaches 0 of h plus 7. And then I'm going to plug in finally because I'm simplified. And I get that the slope equals 7. So does this look like it can have a slope of 7? I do want to tie this back into the other lesson on 11.2. Let's say, for example, right here, if I wanted to use direct substitution property, it is a rational function, but 0 is not in the domain of h, so I can't do it. It isn't until I get down to that last step before I plug in 0 where it meets both conditions and I can just do direct substitution. Keep in mind, once you substitute, you no longer write the limit. You are actually completing that mathematical operation. So the last part of this says to find the equation in slope-intercept form, which is y equals mx plus b. In order to do that, I am going to start and point slope because guess what? I have a point for 12 and I have a slope, so it just makes sense to me. I like it so much more. Feels like less work, probably isn't, but you go with what you know. So y minus 12 equals 7 times x minus 4, and then y minus 12 equals 7x minus 28. So then y equals 7x minus 16. So that is the equation of the line. So not only did I just find the slope, but I also wrote the entire equation. If you look at your picture, this line is going to be coming way down, probably at -16. Not probably, it will be. Just pointing out that this is point slope form. Okay, I just wrote point slope. I'm sorry, this is slope intercept form. Shame on me. Okay, so next what we're going to be moving on to is the derivative. So what I love about the derivative is that it gives an equation for the slope at any point. So if you ever have a situation where you need to find the slope of a line tangent to a graph at more than one point, like 2 or 3 points, the derivative is going to be really helpful for that. It's going to cut down on your time a bunch. So the only difference between the derivative and the slope of the tangent line is that we now use x because x can change. That's at a specific point, and this one is not. So this says consider the function x cubed minus 2. Find the derivative. So notation for derivative is f prime of x. It looks like f apostrophe x, but it's read as f prime of x, and there's actually something called the second derivative. You can do a third derivative, and they just add apostrophes for more variations of derivative. So find the derivative. Okay, let's use the definition. We can plug and chug. F prime of x equals the limit as h approaches 0 of f of x plus h. Okay, so here's our function. Right here we have f of x plus h, and here's where we have x cubed minus 2. So if they're asking for f of x plus h, that part is going to look like this. X plus h cubed minus 2 minus the next piece is f of x. So remember, we started putting everything in parentheses when we were doing this because if it has more than one term we have to distribute. all divided by h. So we're just going to color code this real quick. We have, this is the f of x plus h piece, and then the f of x piece is going to be right here. Here's f of x, and then in our equation, this is where we took the definition and applied it right here. Okay, so now we just have to simplify. Remember, no puppy killing here, so you might be going like, oh my gosh, I don't want to do x plus h cubed because that means that I have to sit there and do x plus h times x plus h times x plus h. Here's the thing. Mathematicians don't like doing that either because it's redundant and repetitive and just kind of annoying for them because they already know how to do that kind of math. So that's why they came up with those little tricks that we've already learned. So we have Pascal's triangle and our chart. We have x cubed, x squared, x, and then 1. And then we have h cubed, h squared, h, and then 1. And then for the triangle, 1, 1, 1, 2, 1, 1, 3, 3, 1. 1, 3, 3, 1. It's nice when there's no coefficients other than 1 in front of our variables. So there we go. So you might have thought, oh, I don't want to do that, but then it just took us like 10 seconds to do if you know the pattern. Obviously, if you don't on a test, you're going to fall back on multiplying out like that. So we have, what do we have? We have x cubed plus 3x squared h plus 3x h squared plus h cubed minus 2, so that was all the highlighted yellow part, minus x cubed plus 2 all over h. The x cubes are opposite signs, and so are the 2 and negative 2. So again, writing our limit on every single step of the way. It's a mathematical operation that you're applying to this rational function right here. Sometimes students will do something silly and they will write the equal sign here in between the limit and the rational function, probably just from lack of experience with limits. So be careful with that because you're taking the limit of this polynomial function right here, so it makes sense for it to be right next to it, not with an equal sign right there. So what I'm doing now is GCFing and factoring out what they have in common, which is h. The h's are going to cancel. It's a pretty typical pattern for derivatives. And so I have the limit as h approaches 0 of 3x squared plus 3xh plus h squared. And now I'm going to do my 1-2 check just to make sure direct substitution works. It is polynomial. I know it's weird because there's x's and h's, and 0 is in the domain because there's no denominator. So now I'm going to evaluate this right now, and I'm going to plug in 0. So what happens when I do that, when I'm plugging in 0 for h, and again it makes sense that I'm plugging it in for h because that's the limit as h approaches 0. So what I end up with is just 3x squared. So my derivative of this function is 3x squared. And you're like, okay, great. Remember, this is giving you an equation to help you find the slope at any point. So as long as we have the x value of the point of tangency, then we can find the slope, which is exactly what a derivative is. So find the slope of the tangent line to the graph of f at x equals -1. So we want the slope, which is an application of the derivative. So we need to plug in f prime of -1. So the slope is 3. So if you were to take this, which I don't have my graphing calculator in front of me, but if you were to take x cubed minus 2 and then draw a tangent line at -1. This would be the slope of that tangent line right there. Now, how do we write the equation of that line in point slope form? So point slope is y minus y1 equals m times x minus x1. Okay, so we go y minus, oh no, I can fill out that the slope is 3, and then I know that x1 is -1 from the previous problem, but I don't have the y value that corresponds to that. Well, what you have to remember, we can actually draw a quick graph right here. X cubed is like the graph that goes like this, and -2 means it's going down 2. So it's kind of doing something like this. So at -1, slope of the tangent line is 3, so that's like this point coming down right here and intersecting when that's, so if -1 is on the tangent line, -1 is also on the equation that we started with. So if I want to find the y value, I just do f of -1 because it's a point of intersection, so it's on both graphs. So I just plug it in to the equation, x cubed minus 2, and then go from there, which should make sense. It's just where you're getting it from. Okay, so in this problem over here, they told us at the point 412, but here they just gave us an x value, and so we can use the information that we have in our problem to find the y value. So that's -3, so then it's y plus 3 equals 3 times x plus 1. And that's the slope of the tangent line in point slope form. So now that we've kind of seen both of these, what I want to point out to you guys real quick is you don't have to write this down, but I just want to show you guys the advantage of the derivative. So I am going to just put up some work that I have done to show you guys that. So let's go back to our original problem right here where we found the slope of the tangent line at 412. And we were just looking at a specific point, so we use this formula. So then again, what if I asked you for this point at -1? So if I asked you for that point at -1, and you were instructed to find the slope of the tangent line using the formula right here, you would have to do all this work again. And then what if I said at 3? Then again, that's a bad tangent line. It doesn't look like that. It looks like that. At 3, then you have that again. So you're doing all this work over and over again. So what's the benefit of the derivative if you have multiple points? So here's that same equation from the very first example. And here's where instead of doing just the slope at a specific point, I decided to find the equation for the slope. So I took the derivative, I do all the math, simplify, and I get to here, this is the equation for the slope. So at 4, which is the first point that we were given, I can find the slope by plugging in the x value. So 2 times 4 minus 1 is 7, which is exactly the slope that we got here. And then if I said, what about at 1? I could just take that derivative equation and plug in 1 instead of having to redo all that math that I had to do. And then what if someone said, now it's 0? I could just plug right in there and find the slope so much faster. That's why mathematicians use the derivative, but you do have to start, you do start specific before you go general. So that's why we're learning both. Both will be on your test. How will you know which one to do? It will be really obvious. It'll say, find the slope of the tangent line. And if it says find the slope of the tangent line, then you use this slope of the tangent line formula, m tan. And if it says find the derivative, you have to know derivative is f prime of x. And then you use this. Okay? So it's not meant to be tricky. It's just a matter of studying. Okay? So the more times you see it, the easier it'll be. So I'm going to put a tricky on this last problem that we have. So you know what that means, flashcard problem, and we don't have tons of flashcard problems. There's only 3 actual examples here. So you might want to pull another one from either homework or the review worksheet or whatever. So we are just going to go right into it. We're going to do f prime of x because it says derivative equals, derivatives are limits as h approaches 0 of f of x plus h. So here's the x. So I'm going to do 3 over x plus h minus f of x, which is 3 over x, and then all over h. So notice I didn't put the limit over h because that's not part of the definition. It says this is. Okay, so let's simplify this using complex fraction simplification procedures. So this needs an x plus h, and this needs an x plus h. This needs an x, this needs an x. So I get 3x, and you're going to be really careful here. You are going to go -3 times x and -3 times h because that negative goes to everything, or that subtraction goes to everything to the right of it. So 3x minus 3x minus 3h all over x times x plus h. So that was our numerator, all over h. And I'm going to make this h over 1 and simplify and copy dot flip in both the next steps. So the 3x's cancel each other out. So then I have -3h all over x times x plus h times 1 over h. And look at the beauty in that math right there. Rigged. And so then we get that this equals the limit as x approaches 0 of -3 over x times x plus h. And we're going to do our 1-2 check so we can use direct substitution. Check, check, right? Because it is a rational function, meaning it's written as a fraction. And 0 will be in the domain because if you plug in 0 here, x plus 0 is x, and so it's still, that would be x squared, which is actually what we're going to do. So we get -3 times x plus 0. You could even FOIL this out if that makes you happier, which equals -3 over x squared. So f prime of x equals negative, I'm going to be a mathematician and write it next to the fraction bar. And there we go. Okay, so there's our derivative. So now we know that whatever x value we plug into here, that will be the slope. We will calculate the slope of the tangent line at that x value. So for part B, it says, find the slope of the tangent line to the graph of f at x equals -1. So at x equals -1, I'm looking at f prime of -1, which is -3. And then at x equals 3, the slope, I'm going to put that in there, just the slope equals the derivative at 3. So we do that same math. And of course we reduce our fractions. So we get -3 1/3. So I'm going to show you what 3 over x looks like. The graph of 3 over x actually looks like this right here. And you know, when x is, you can make a table to figure this out if you want, but when x is 1, y is 3. When x is 3, y is 1. So it has this shape, and then it is odd, meaning f of -x is a change in sign, so it is symmetric about the origin. So it looks like that. So then let's look at this. When x is -1, which is here, if I draw a slope of a tangent line, is that a slope of -3? So are you going like down 3 over 1, down 3 over 1? That looks about right. And then when we go to 3, which is right here, and I do my tangent line at that point, kind of like that. It might be a little less pronounced. Actually, let me give you a better picture just because I have it. Like right here. Oh, this one's so much more pretty. Here's the 0.3 and then at -1/3. So you can see that slope. So you guys can always check in your graphing calculator. You can always plug the equation in and then see if your slope answer makes sense if there's time. Alrighty? Okay, well, that is the derivative. Woohoo, calculus! At any point. So if I asked you right now to find the slope of this, the slope of the line that hits this parabola at -1. So like right here. Guess what? You get -1, you get the y coordinate, you have to go through all of this again in order to find that. What if I then said, okay, now I want to know at 0. So slope of the tangent line at 0, and you have to find the y coordinate, go through all of that, all of this slope of the tangent line again. Well, of course the mathematician was like, hey, there's got to be a shortcut to where I can just find the slope using a formula. Enter the derivative. So again, this is read as f prime of x, and it gives the equation for the slope at any point. It's the tangent line, the slope of that tangent line.